I wanted to revisit question 21 on the math subject GRE practice test really quick. The reason why is because when I originally solved this problem, I think I made the comment that there's probably a reason the test makers are asking for 5x plus 3y. There's probably some significance to these coefficients here. I bet if you're really clever, you can figure out a linear combination of these two congruences that give you 5x plus 3y directly, right? Rather than actually going through this kind of longer method where we solve for what x is congruent to and then use that to solve for what y is congruent to. Or I guess I went in the other direction, but whatever, solve for each of the variables. I'm pretty sure I made some comment like that in the video. I was at least thinking that. But then I was like, oh well, moving on, and didn't really take it any further. Well, thankfully, somebody made a comment on the video. Let's see down here. Kyle apparently made this comment and was able to, in like 2 sentences, point out how you could solve this problem in, I don't know, like 15 seconds. And I liked it so much that I wanted to go back and kind of demonstrate it in a new video. So thank you, Kyle. Anyways, what Kyle did essentially was looked at the coefficients on x and y that we want to come up with. We want to end up with 5x and 3y. Well, what would be an easy linear combination of these two congruences to leave us with either 5x or 3y? I mean, maybe the most obvious one is we could get 5x if we took 1 copy of this congruence and 2 copies of this congruence, right? 1 copy of this congruence is just 3x plus 2y is congruent to 5, and 2 copies of this congruence, in other words, scaling both sides of this congruence by a factor of 2, would give us what? 2x plus 14y is congruent to 2. And then if I sum these two congruences, 3x plus 2x gives me 5x, 2y plus 14y gives me 16y, and 5 plus 2 gives me 7. But 16y mod 13 is congruent to 3y. So I get that 5x plus 3y is congruent to 7 mod 13. Wait a minute, 5x plus 3y, that's exactly what the question is asking for. Kyle was able to figure out that the answer is 7 without ever figuring out what x or y themselves were congruent to. All right, I think that's pretty cool. You might argue that Kyle got a little bit lucky, right? What if instead of asking us for 5x plus 3y, the test makers asked us for, I don't know, 5x plus 4y? Well, 2 comments there. The first one is, again, I don't think 5x and 3y were chosen at random. I suspect that the test makers were kind of benevolent and they chose coefficients here that would be conducive to clever methods of solving like Kyle came up with over here. But even if these coefficients were completely random, if we just focus on a linear combination of these congruences that gives us one of our 2 variables, it doesn't matter which one, maybe we'll focus on the 5x, then because we're dealing mod 13, there's only 13 options for which the coefficient on y could end up being congruent to. So even if these coefficients were chosen completely at random, we have a 1 in 13 chance of getting the correct coefficient on the y's if we only focus on getting the correct coefficient on the x's. And you're like, yeah, 1 in 13, I don't love those odds. Right, but it's easy to play this game over and over again until you win. You only have a 1 in 13 chance of winning each time you play, but there's no limit for how much you can play. It's pretty easy to come up with a different combination of these 2 equations that leave you with the coefficient on the x that's congruent to 5. For example, 2 of these would give me 6, minus 1 of these would leave me with 5, right? 6x plus 4y is congruent to 10 mod 13, and negative x minus 7y is congruent to negative 1 mod 13. If I sum these 2 equations, I again get the 5x that I'm looking for. 4y minus 7y is negative 3y, but negative 3y is congruent to 10y mod 13, and this sum or difference would be congruent to 9. So if the test makers didn't ask for 5x plus 3y and instead asked for 5x plus 10y, I'd be golden. And you're like, right, but what if it wasn't? Well, then just play this game again. Find some other linear combination of these 2 congruences that give you 5x. I don't know, 3 of these would give me 9. Subtract 4 of these, I get 5. 4 of these gives me 12. Subtract 7 of these, and I'm back to 5. You're like, yeah, but pretty soon the numbers get pretty big. Okay, then take advantage of the fact that we're working mod 13. You don't need a linear combination that makes the coefficient on the x equal to 5. You need a linear combination of the 2 congruences that makes the coefficient on x congruent to 5. So if you want to take advantage of the fact that 5x is equal to 18x when we're dealing mod 13, then you can just come up with a linear combination of these 2 equations, like, I don't know, 5 of these and 3 of these maybe, that give you 18x because you know 18x is congruent to 5x, or negative 8x for that matter. So if I took negative 3 of this congruence, I'd get negative 9x minus 6y is congruent to negative 15 mod 13. And then if I added 1 of this congruence, I got 1x plus 7y is congruent to 1 mod 13. And then when I sum these two, negative 9x plus 1x gives me negative 8x, negative 6y plus 7y gives me 1y, negative 15 plus 1 gives me 14. If I reduce these mod 13, I get that 5x plus 1y is congruent to 1. If that were the coefficient I was looking for, I'd be done again. And what else is cool is I can use these new congruences that I've come up with to generate more congruences pretty easily, right? This plus this minus this would leave me with the 5x, right? 5x, 10x, subtract this, you're back to 5x. So then 3y plus 10y is 13y, minus 1y gives me 12y. So 5x plus 12y would be congruent to whatever 7 plus 9 minus 1 is. What's that, 15? So it's congruent to 2 mod 13. I can pretty quickly generate different congruences where the coefficient on the x is a 5, and I get a different coefficient on the y to figure out any linear combination of x's and y's that the test makers could have asked for. Anyways, just thought that was worth adding. Thanks again, Kyle.